Okay, everybody, this is what you've been waiting for. This is the last geometry topic of the school year. Woohoo! What we want to do here is, again, finishing up on circles. We're talking about equations of circles on a Cartesian plane, on an XY axis. Okay, we want to talk about what the standard form is, what it looks like, and what information we can put into it when we write the equation or get out of it when we're given the equation. So here's what the equation looks like. The equation says that if I have x minus h quantity squared plus y minus k quantity squared equals r squared, that will represent the equation of a circle. Okay, now here's what you know about that circle. That circle has coordinates, has a center at h, k, whatever h and k are. And it has a radius equal to r. Okay, so given this equation, okay, I now have enough information where I could do a rough sketch. Okay, and that's kind of important. I could do a rough sketch to see where it's at on an XY plane and about how far, what ground it covers in terms of different quadrants, etc. Okay, so let me give you an example. And let me tell you that, let's say we have, for example, x minus 3 quantity squared plus y plus 1 quantity squared equals 9. Okay, that is the equation of a circle in standard form. Okay, equation of a circle in standard form. Now, here's what I know based on that. And here's the shortcut. Okay, first of all, this equation is actually derived from the distance formula. Okay, so we know the distance formula is d equals the square root of, we have x1 minus x2 quantity squared, y1 minus y2 quantity squared. If you would change that d to an r and then square both sides, it starts to look a lot like this on how you rename, when you rename the different characters. Okay, so, but here's the thing you want to do. To find h, take this first quantity and cover up x. Now, see the minus 3? Take the opposite of that. H has to be a 3. Okay, H has to be a 3. Okay, to find K, go to the second quantity, cover up the Y. See the plus 1? Take the opposite of that. You get a minus 1. There's your center. Okay, take the opposite of what you see after you cover up the variable, just the variable. Now, to find R, the radius, you take this number over here, okay, and take its square root. The square root of 9 is 3, because according to the formula, this is r squared. I don't want r squared, I want r. So square rooting that gives us this value. So you've just identified the information for that circle. Okay, so let's try another one. Okay, so if I have x plus 5 squared, y minus 2 squared equals 1. Again, find the center. Cover up the x. Opposite of positive 5 is negative 5. Cover up the y. Opposite of minus 2 is plus 2. Square root of 1 is 1. And then one other little trick thing they might do to you is, if I were to do this to you, x squared plus y squared equals 25. Okay, now, if the x's and y's are not written into quantities like above, then it's because the h and or k values are 0 because this can be written as x minus 0 squared plus y minus 0 squared, okay? And the 25 is the same thing as 5 squared. So look what you got. You have a center at 0, 0 and a radius of 5, okay? So they'll do some of that to you. They'll give it to you in standard form, whether it's simplified or not. Be careful that zeros are possibilities. Now, it's also possible that your radius will be left as a radical. Okay, so for example, if you get something where you get the r equals 2, okay, the square root of 2 is just that, square root of 2. Okay, square root of 2 isn't 1, so be careful. That's not, don't try to divide it. Leave it as a radical. Don't change it to a decimal. Okay. The other thing they're going to do is they're going to maybe give you information and ask you to plug into the formula so that you can write it. Okay. So let me just throw out a number here. So let's say, for example, if I have that, I have a center at 2, -4, and let's say I have a radius that's equal to 2.2. Okay, bring it down just a little bit. Okay, now with this example, then I need to take the equation and I'm going to plug in. So you start out with the form of the equation, and now I start plugging in numbers. Okay, and be careful, you want to plug in the signs as well. So I'm going to use parentheses. I don't always need to use parentheses, but I'm going to just so you can see them as they're plugged in, that they're still there. And then my next step is going to be to go through and then simplify. Okay. Now this parentheses don't do anything here, so I can just call this x minus 2 squared. They do something here. They separate the double sign. And this is what happens when you get a plus, is you actually have to change that a double sign. So this becomes a y plus 4. And then when I take my calculator and take 2.2 and square it, I get 4.84. Okay, so that's the other side of the coin. If I give you the center and radius, be able to plug in and simplify. I don't want to see any double signs in that equation, and I want to see those numbers simplified as well. Okay, now number 3 is a good problem to look at. This is on the reteaching page, the first page. It says, I have a center at -2, 3, and I have a point on the circle of +2, 3. And it says, write the equation of the circle. Okay, well, here's my problem. And they show you an example up there above in example number 1, part B. So you can follow that as well. But I don't have the radius. I can't plug into the formula without having the radius. And this is where, when I talked about distance formula a minute ago, this is where this will come into play. So if R is going to equal, I want to plug in, and it really doesn't matter what order, but I'm going to go from the point to the center. Okay, x coordinates 2 minus -2 squared, and then 3 minus 3 squared. Okay, so when I go through and simplify that, this becomes 2 plus 2, which is 2 squared, which is 4. This simple cancels out because it comes as 0. So r equals the square root of 4, which is 2. Okay, so using the distance formula, I found that the radius is equal to 2. Now, with the other one, now that I've got that one, I can go back and now plug in. Okay, so I'm going to plug into with the standard form. Okay, so x minus h, which is negative 2, squared, plus y minus 3 squared equals 2 squared. Now notice that I'm using the center. Once I found the radius, I don't need that point anymore. Okay, don't use that as your center. That was just for the purpose of finding your radius. Then go back to the center. The double negative here changes to a plus. And so there's your equation. Okay, so given center and radius, be able to write the equation. Given center and point, write the equation. That's, I don't know how many of those they're going to do, but they're not going to stray from this much at all. Okay, so you shouldn't see a whole lot of difficult problems. Most of them are going to be very basic. On the next page, on the back side of the reteaching, number 7, they want you to, it says graph the circle. I don't want you to graph it. I just want you to tell me the center and the radius. Okay, tell me the center and the radius. So if I know that x squared plus y plus 2 quantity squared equals 1/2, okay, then remember what we said. If there's a character missing, that means it must be a 0. Oops. Okay, so cover up x and y and take the opposite of what you see. So I have a center at 0, -2, and I have a radius that's the square root of 1/2. Okay. To be completely correct, remember we can't have a fraction underneath. So square root of 1 over square root of 2, which equals 1 over the square root of 2. Oh, but remember we can't leave a square root in the bottom. So if I multiply by square root of 2 over square root of 2, your final answer, there's your radius. Okay, so there's your center, there's your radius. And that's all I want you to do for problems 4, 5, 6, and 7. Okay. On problems 8, 9, and 10, and there's another section on the next page similar to this. Okay. They've put a map more or less on a XY grid, and they've noted the location of several points of interest on this. And they want you to know, does this point lie inside the circle, outside the circle, on the circle, basically. Okay, that's what they're asking you to do. Okay, so here's what they know. Okay, it talks about, we have damage done from a meteorite can be expressed by the equation x minus 3 squared plus y minus 3 squared equals 9. So I'm going to copy that down to start with here. Okay, so I know that this thing has a center at 3, 3 and a radius of 3, 3, or radius of 3, sorry. When you take the square root of 9. Okay, now they give you 3 different situations here. Okay, and what they're asking you to do is plug in the coordinates. Okay, and we're trying to test it here. So number 10 is a pig pen. And I want to know if the amount of damage is expressed using that. Okay, did the meteorite damage the pig pen? So it looks to me, if you follow the coordinates and they go by twos, 2, 4, 6, 8, 2, 4, 6, 8, 9. It looks like the pig pen has coordinates 8, 9. Okay, so here's what I'm going to do. Okay, now don't go by the circle that's given there. Okay, so don't go by there. Well, here's what you want to do. Plug those numbers in to the formula. Okay, so if you have plugging in these, we got cheer class going on in the other room here. So, okay, so I'm going to take those and I'm going to plug in the formula. Here's what's going to happen here. If you plug in and you get a number greater than 9, okay, then that means it's outside of the meteorite area. If it's less than 9, then it's inside. If it's equal to 9, then it's right at the edge on that border. Okay, so here's what I want to do. Plugging in the numbers. I get 8 minus 3 squared, and I have 9 minus 3 squared, and 9. So here I have 8 minus 3 is 5. Okay, so you have 5 squared and 6 squared. So in this example here, clearly we've got a number 25, 36 is 61, okay, which is greater than 9. So we would say that the pig pen is actually outside of the blast area, so to speak. Okay, so less than 9 would be inside, greater than 9 outside, equal to 9 is on the perimeter. Okay. And then I had to catch the bus. So yeah. Hopefully. What? Who got? Oh, yes. Well, we see Timmy. Oh, y'all got some lunch? Awesome. Yeah, it's hard not to eat it when we're going out to the country with the food. You know, today we were carrying soup, and we get on those slippery country roads, and oh my, it was not good. But oh yes. Oh, okay. Okay, so the last part of this then, practice A, is again just more of the same, and again, nothing real different than what we've already been talking about. So questions 1 through 6 are matching. They give you the equation on the left and the center and radius on the right. Okay, so for example, if you're looking, I'm looking at number 5. Okay, x plus 3 squared, y minus 5 squared equals 16. So cover up x and y, take the opposites. I have a center at negative 3, 5, and a radius of 4. So negative 3, 5, radius 4. So at number 5, I would match that up with letter E. Okay? Questions 7 through 12, you're asked to give the center and radius of each circle. And again, just like you did up above here, but this time you don't have choices to pick from. So all of those will work out nicely, no messy ones to deal with there. On 13, 14, and 15, they give you a picture, and we want to identify the information and then write the formula. So number 15, you have a center at 1, 1, and you have a radius of 1. So plugging all that information in, I could write that x minus 1 plus y minus 1 equals 1 squared, which is just 1. So there is your equation for that one. 16 through 19, more of the same. Okay, let's use number 17. I'm going to plug in a 0 in one of the spots. So this would be x minus 0 squared, y minus 1 squared equals 2 squared. But I don't want to leave that minus 0, and I don't want to leave 2 squared. So I can simplify that by saying x squared plus y minus 1 squared equals 4. And then on the last 6, again, you're going to be testing some points here. Okay, so here's what you're going to do. You're using this formula, x minus 2, y minus 2, and 4. And here's what will happen. If you know that x minus 2 squared plus y minus 2 squared is equal to 4, then you're going to write that that point lies on the circle. Okay, if it equals 4. If it's greater than 4, it's going to be outside or in the exterior, let's put it that way, the exterior of the circle. And then less than 4 means that it would lie in the interior of the circle. Okay, so 24, I'm going to plug in the 4 and the 4. Okay, now let's do 25. 25 is the number 3, 2. So I have 3 minus 2 squared, and I have 2 minus 2 squared equals, well, and equal, I'm going to put maybe equals 4. So this is 1 squared, 0 squared, and 4. And so you get 1 over here, a 4 over here. Okay, 1 is less than 4. So the point 3, 2 lies in the interior. Sorry, did the whole thing there without you watching, so I'll go through it again. Okay, so here are your formulas. X minus 2 squared, y minus 2 squared, and 4. If those are equal, then you put on. If this is greater, you put exterior. Less than, you put interior. So when I tested this, I plugged in the point 3, 2. I got 1 squared, 0 squared, and I got the 4 here. So I got 1, which is less than 4. Less than means it lies in the interior of the point. Okay, so the first part of this where you're writing the equations and finding the center and radius, that's more of what the test is going to ask you to do. It's not going to get so much into these other aspects of using the formula for finding inside and outside. And so And it's going to be limited. By the time you get to this point in the test, there's only going to be a couple questions. But if you've got questions about any of this stuff, again, send me the email. I don't think you'll have a whole lot of trouble with this worksheet. Okay, and then go from there. I'm going to leave you some instructions. That's it for chapter 10. I'm going to leave you some instructions on announcements there about the test. But as soon as you get these things done, switch over and start working on that, and that'll be all that's left for this school year. Okay, so thank you.